Hello, everyone. Welcome back. We are now doing a critique for week 8 of the Dev Challenge. My name is Roland, and I have with me here today Ronald. Hello, Ronald.
Hello, everyone. This week we saw a lot of different submissions again, but we saw, I guess, primarily two different kind of approaches to the same problem. So let's go ahead and get into exploring that.
Okay, awesome. Thank you, Ronald. So just a quick recap on what the problem is. For lack of a better name, I'm calling this challenge the deduplicate names. So we have to deduplicate names by adding bracket x, where x is an incrementing number, to make them unique. So these were the problem sets that we provided you. The first one, John, Jane, June, and Joe, they're all unique. So the output is exactly the same strings. The second one, hello world, and hello world bracket 1. So the output would be hello world, for the first name. The second name, because it's already a duplicate, then we would need to append bracket 1. And then the third name, hello world bracket 1, that already exists in our output, so we need to add another bracket 1 to it. Okay. And then for this data set, is similar but slightly different. If you look at the input, it's hello world, so then we output hello world. The second string is hello world bracket 1, so then it's unique because we don't have that in our output yet, so we're going to output it as is, hello world bracket 1. And then the third string, hello world, that already exists in our output, so then we have to put an index. Now, the first index we were going to try is bracket 1, but bracket 1 already exists in our output. So then we have to increment that to bracket 2, and then that's what we output. Okay, this one, it's 4 highs, high. So then the first one is unique, so that goes out as is. The second one, we add a suffix, bracket 1. And then the third one, we add a suffix, bracket 2. And then the fourth one, a suffix, bracket 3. Okay, and then for this one is getting a little bit more complicated. We have high, so that goes out as is. Then high brackets 1, so that one is unique, so that goes out as is. High bracket 2, that's also unique, that goes out as is. And then the next high, that's no longer unique because high is already in our output. So we're going to try to put an index 1. But that already exists, so then we increment to index 2. That also already exists, and we get to index 3, which then goes out because that's unique. And then the next string there is high brackets 1. So again, we go through the algorithm. Does high brackets 1 exist in our output? Yes, it does. So since it does, then we have to append another suffix. So in this case, we're appending brackets 1. And then the last high, again, high is not unique, so we try to append 1, which is not unique. We try to append 2, which is not unique. We try to append 3, it's not unique too, so we get all the way up to 4. Okay, great. And then this last one, Ronald, do you want to explain this one? I
Sure.
feel like I've been explaining everything.
So this one is quite similar to the previous one, but it adds a couple more different conditions to it, which are kind of tricky. So high starts off perfectly fine. It's unique. Then we go to high bracket 1 and high bracket 2, which is pretty straightforward. The next one is the given high bracket 1, bracket 2 already. So that sets up for the fourth element, where you need to be able to handle basically recognizing that the next increment is not high bracket 1, bracket 3. It's high bracket 1, bracket 1, because it hasn't been taken yet. And then the following one is now high bracket 1, bracket 3, because high bracket 1, 1, and 1, 2 are already taken. So the next one you need to recognize on the fifth element is high bracket 1, bracket 3. And similarly for the last element, the next available number would be high bracket 1, bracket 4.
Okay, awesome. So I'm very happy to say that all the submissions this week, they all got the right answers. So awesome. Good job, everyone. So now let's take a look at the submissions, and we're going to provide some critiques. So this first one was submitted by, I believe this is Faisal. Yeah. Okay, this one was submitted by Faisal. Before we look into the code, let's just walk through his algorithm graphically here. So Faisal creates an array, and this array would contain a list of the new names, so the modified names if needed. And then he would go through all the names, input names on the left side, and then it would populate this new list array with all the new names. Okay, so in the, like for example, hi, since hi is unique, then it would just copy hi over. Okay, so and then if it's not unique, then it would find the appropriate index to add, and once it's found the appropriate one, then it will populate new lists with that modified name. Okay, so let's take a look at this code. What are your thoughts on this code, Ronald?
So actually the next couple of submissions are all kind of based on this algorithm. So I guess for this style of algorithm, I guess we can maybe just talk a little bit about I guess the approach that they took, where they just check for duplicates, and if there's no duplicates, then it will basically that's the next element, that they would take the element, and if there is duplicates, then they will figure out the next number to they would compute dynamically basically what the next element number should be, and then put it into the array. Yeah,
that's right.
So for this one, I guess for the most part, it's relatively easy to understand, but I do see two different issues that happen in the while loop. And so the first one is when he goes in and he does the set operation twice, which one of them is actually redundant because it's doing basically the same ish work twice. So in the first set, the dummy is set into the input array, and then in the next set he takes that dummy element that he just set, and he then goes and appends the new number to it. So this could have been done all in one shot if he just instead of setting the dummy into the input array and then pulling it out again and then putting the number in, he could just do it all in one shot. Then the second problem that we took issue with is that the input string array that he's setting is actually modifying the input parameters, and we've discussed this previously, and that's probably a bad practice. And again, maybe it's from influence from other languages, that different languages operate differently with input parameters, but for Java, if you're modifying the input parameter, it actually affects the original element. You're not doing you're not working on a copy. So this is actually I guess more of a bad practice, because when you're modifying the original input, the programmer might not expect that original input to be changed after they run this function. So yeah, I guess we definitely have talked about this before, but we've seen this actually in this particular challenge. We see it in quite a number of submissions. So yeah, just something to not do.
Yeah, I can't tell you how many times I've encountered code, and some of them even I wrote myself in my earlier years, where I've encountered a bug and I couldn't figure out why this bug was happening. I have an object or some data structure, and then later on it takes on a different value than what I expected it to, and it's because of this behavior where this function or method call behind the scenes modifies this data structure. So if I call fixed file names with an array, After calling fixed file names, my array might now have different values than what it had prior to calling fixed file names. And so these side effects could bite you, and many times it has, right? So for something like this, it'd probably be better, like what Ronald said, is to make a copy of input string array here, work with that, and then return that copy here. So then whoever calls fixed file names, whatever they're passing you, you're not modifying their work, right? So you do your own work, and then you give them a brand new data structure, and then their original data structure is not modified. Like what Ronald said, this is a side effect of Java because of C, C++, its history being derived from C, C++. C++ deals with pointers. Java doesn't deal with pointers anymore, but it hasn't completely removed it. So things like that is you can look it up. This is a pass-by reference instead of a pass-by value. So we won't explain that now, but if you're interested to know what that is, leave us a comment and maybe we'll create a video to explain what that is. But in modern languages, they've done away with this because we've, the whole industry has evolved and realized that something like this has caused so many bugs in so many different systems. So modern languages like Swift, for example, you can't modify the input parameter. Or if you modify it, you're modifying a local copy. You're not modifying the original one.
Mm-hmm. And yeah, so I think this is just a good practice to, when you're working to be a better developer, to understand those nuances of the different languages. And that's kind of part of it, because most likely these bugs won't crop up until you're least expecting it. So just when you're making those decisions, when you're writing functions, just know the language and what it does with input parameters, and if it's doing a copy by reference or value.
Yeah. And one last thing I wanted to talk here. This submission here, Faisal, you created a new function. I didn't put it in here, but you created a new function called check duplicate. Actually, you don't need to, because there is a built-in function called .contains that you could have used. So then instead of writing your own, you could have just called .contains. Okay, awesome. Let's move on to the next one. So this next submission, this one is by William. Okay, so William uses the same algorithm. What do you think about this, Ronald?
Well, this one is a little bit more straightforward in the sense that when we're looking through this code, it's relatively easy to understand. But I guess there is still a bit of improvement that we could have here. The while loop is a little bit needlessly complex, and we can see in the next submission how more compact it can become. And like, for example, the found variable, like the next submission doesn't even use something like that. So
yeah,
I guess for the most part, this is relatively good, but I guess there could be more, like this could be made a little bit more concise overall.
Yeah. I mean, what I like about William's submission is that he's not modifying the input array, so which is good. He's creating a new array. Oh, one thing I forgot to mention, comparing this submission with the previous one, if you look at William's submission here, in his while loop, while he finds a duplicate, all he's doing is he's creating a new string, but he's not adding anything to new list until he knows that he's found the right name to add to it. In Faisal's algorithm, it's a bit hard to see now, but every time through the while loop, even if it's a duplicate, he's setting something in the input string array, and then the next time around he just overwrites it. So if let's say the index is now up to 100 and you're starting at 1, then this algorithm will write the index bracket 1, index bracket 2, all into the same location, index bracket 3, all the way up to 100. So that's 100 writes, 100 sets, or in this case, it's a double set. So because you call set twice, so there's 200 sets. Mm-hmm. While in this algorithm, it would just be one add here at the end, because you know that it's a duplicate, so there's no point in doing that.
Yeah.
So, Ronald and I were talking about this earlier. So we have different opinions here. So one thing that I was looking at, you see here, this is spacing. So this is formatting, right? So you see the for, while, and ifs here. All of those keywords have a round bracket that comes after it. So what I was telling Ron is I'd like to see an extra space after the for before the brackets. So an extra space after the while and after the if. But Ronald, you feel differently about this, right?
Yeah. Well, personally, I don't mind it too much. But it is a valid concern in terms of like if you want to enforce a code style. But I would also argue that if that's something enforceable, you could probably set up a linter for your code base so it automatically corrects that for you. But personally, if I'm working on this code base and let's say there's no linter, personally, I'm not too bothered by it. But yeah, that's just personal preference.
Okay. Yeah. So as you can see, even among developers in the developer community, people have different opinions. So that's one thing to understand is what are some things that are good software development principles that we should mostly all follow, and what are some that are something that I prefer, but maybe not everyone. And the reason I prefer it because I just think it's a little bit more readable with the extra space, and it also differentiates like a for here with an actual method call. So method calls here, like with the add and contains, they both don't have spaces.
Yeah.
And that seems to be the convention. And so in my personal preference, I'd like to, differentiate that from like fors and whiles.
Yeah. I mean, I would probably defer, like, if there is a convention being established already, then definitely follow that convention. Like some companies, they have a very strict code style, or they have a, certain way that they do things. So follow that. But if it's just for, your personal projects, it's really what you prefer, right? So Roland likes the spaces after the whiles and fors and ifs, but if that's, I guess, for your personal projects, if that's something that you don't like, then that's something you can choose, right?
Yeah. Okay, awesome. Great. So let's move on to the next one. So this next submission is by Irene. So just off the bat, this is the same algorithm as the previous two, but it looks the shortest and the cleanest to me. What do you think, Ron?
Yeah, so like I kind of mentioned with Williams, you can see how the while loop is very simple. There's no need for a if-else kind of logic inside the while loop. So just from a kind of simplicity and also reducing the lines of code to achieve the same thing, this is much better. And also it's just a way of structuring your logic, right? Williams did it one way and Irene did it this way. So if you can always get it down to something like this, then this is obviously more preferred.
Yeah.
But yeah, overall, just if you just look at the lines of code, it's achieving the same thing in like a half to 2/3 of the lines that William took to do it.
Yeah. And it's not just reducing the number of lines for the sake of reducing the number of lines. It's still very readable and it's still very understandable. Like when you read through it, okay, so we have a list here. We create a new list called renamed files. We have a for loop. We're going through the input string array. We're taking each name out of the input string array. And then we start with we have another two variables and a numbered file. And then while renamed files, which is our new array, contains the numbered file, we will keep incrementing n and creating a new numbered file. So when that no longer contains it, that means we found a unique one. Then we add that numbered file to the renamed files. And when we're all done with the for loop, we returned our renamed file. So it's very easy to understand. We haven't sacrificed any readability or any understanding of the algorithm. Because I have seen code where it is very short, but it's so hard to, I can't understand it. So that's, yeah.
Yeah. So, yeah, I guess earlier when I was saying like, this is half to a third. Yeah, it's not about reducing the lines of code, but really where can you make it more efficient without increasing the lines of code, right? And still can maintain that, an understanding of what it's doing without kind of doing all these hacks just to reduce it down to like a one-liner, right? I mean, I'm sure there's ways where you can reduce this even further, but you're starting to make it really hard to read and understand what it's doing.
Yeah, that's right. Okay, great. So then this next submission is from Bastian. But before we go into his code, this next group of submissions follows a different algorithm. So instead of an array, they use a hash map. Ron, why don't you explain what they're using the hash map for, or what it's supposed to be? Because they each do it slightly differently.
So because in the examples, you can see that when you first get the inputs, you have it's always going to be appending like a suffix to whatever file name is given already. So if you have a hash map, basically you can map all the elements that are in the inputs, and then you can know what is the latest suffix you should append to it. So if we just walk through this really quickly. So all of these start with high, all of these start with 1. So for high, the latest suffix will be 1, and then high bracket 1, the latest suffix will also be 1. So as you're going through this, when you get to the second high, for example, that would be element number 4, you know that the latest suffix you can use is high bracket 1. And then when you get to the 6th element, you know that the latest suffix you can use at that point would be high bracket 2. Or actually, sorry, high bracket 3.
Yeah.
No, wait, that's wrong. That's wrong. High bracket 2. Because the second and third and fourth element, they already have the brackets appended already. So
yeah, that's right.
So you need to basically append additional brackets to that.
Yeah. Okay. So yeah, like each of the next submissions, they use that. So this dictionary, the left column is the key, and then the right column is the value. So each of the next algorithms use the value slightly differently, but I think the idea behind this is that the algorithm keeps track of what is the next available index to use for creating the new name. Now, so this is Bastian's submission. So my first thought here again is that it's a little bit hard to understand, particularly because you have an algorithm that has a key and a value inside a dictionary, and it's not clear when reading through the code, and the comments don't really help to describe to me what is the significance of the values. So let's say here when we're putting in values 0 here, or this get file plus 1. It's not clear to me what those values are going to be used for. So it's a little bit hard to understand that way.
Yeah.
And like we said before, the input string array here is also modified. So that's not a good side effect. Yeah. Okay.
He also does the put twice, which is a little bit redundant because the second line retrieves what he just did.
Yeah, that's right. So Oh, actually, no. So this one, the first put here puts the string. So for example, if it's a high with, so let's say we have high bracket 1. So this line here will put in high bracket 1, and then the value would be 0. And then this next line here would put high. So high is already in the dictionary, and then he would take what is the previous index of high in the dictionary, and then it would increment that. So it would increment the last index there. So that's what Bastian's doing here. But there's a problem with this too, because I don't know what this +1 is. Are you what you're keeping track of? Because would this increment be better, right? Because you're using this variable called increment here, which you're incrementing so that at the end, this increment is what's used to form your file name, right? So if let's say we're now at high, let's say 100. So increment is now at 100. Shouldn't you be storing 100 here so that the next time through, you don't have to go through the for and while loop so many times. You know that the last one used was 100, then the next one should be 101, right? Because if you're just incrementing it here, then this value could be much lower than 100. So I'm not sure what you were trying to do, Bastian, but you can let us know in a comment what you were trying to do here, and if maybe this optimization is what you were originally thinking of.
Yep.
Okay. Okay, let's look at the next one. This one here is by Mackenzie. So, what's Mackenzie doing here?
So again, it's pretty similar to he has the hash map again, but the kind of more interesting part is kind of the last 3 lines where he does the set and the puts. One thing that we noticed was the last one, the last put there. That one is actually basically he's duplicating what he did in the first put with the second one, because he sets well in the input array he sets the word I,
yeah,
and then he puts into the hash map the same word again with the count. We're assuming count.
Yeah.
And then again he puts the word again in the hash map with 1 instead.
Yeah. So this second line actually overwrites the previous line. So this one will overwrite count. So that second line, the first put, is rendered useless because the second dot put will overwrite it.
Yeah.
Right? Because input string array get I is actually the same as word because we just set it to word, right?
Mm-hmm.
So either that first line hmap.put is useless, or actually what I think we should probably be keeping track of count here, because count was the highest index that we've calculated already. So I'm thinking you probably want to save count, and you don't want to overwrite it here with a 1. So that your dictionary would have the highest index that was last used. So the next time around, you would continue off from there rather than starting back from 1.
Yeah. He did leave us some comments, but it doesn't quite match up with what it looks like the logic is doing. So
yeah,
maybe Bastian, if you this is Eric.
This is Mackenzie. No, this is Mackenzie.
Mackenzie. Yeah. So if you're watching this, Mackenzie, feel free to maybe put some clarification in the comments below.
Yeah. We're interested to know what you were trying to think, or what you're trying to do here and what you were thinking. Okay, great. And then, so this last one is by Eric. So I think for all the submissions using this algorithm with a dictionary, this seemed to me to be the cleanest algorithm. What's Eric doing here, Ronald?
Is there one more slide actually? I'm seeing 5 still.
Oh no, this is. Oh, sorry. Okay, there.
Yeah, there you go.
6, yeah. Okay, so yeah, this is Eric's submission. This is the cleanest one, I think, for this algorithm. What's happening here?
So just like the last couple, Eric is using the hash map again, and so basically he figures out if there is a unique key or not, and if it does contain the key, then he sends it into a helper function called new name, and that's where the logic of figuring out like what name or what suffix to give the file happens.
Okay. Yeah. See, just the act of breaking out this function here and calling it here instead of embedding it makes the code that much cleaner. And even if it's just a few lines, right? It just makes it cleaner because now I can read this function here, and it's very easy for me to understand that. Knowing that new name will do something, and then I can read new name in isolation here.
Mm-hmm.
So yeah, so this is clean. The only critique I have for Eric, again, this I think is the cleanest of all for this second algorithm. I only have 2 critiques. One, again, as I mentioned before, you're modifying the input parameter, so that has side effects. And the second one is I would. We've said this before, I want to know what you're using the index for. Because, when you're writing this, it makes sense in your head, right? But then when you read this like 6 months later, you would have forgotten what the index for. So put in some comments or some description as to how this data structure is formed. Even if it's as simple as saying, okay, this is my dictionary. I have a key and I have a value. And then just describe what your key is and what your value is. So what it stands for. Even something like that will really help. Right? Okay. Awesome. Yeah. So
for these two, for this week's challenge, because we kind of saw 2 different approaches, we're gonna actually take 2 winners this week. We are going to select Irene for the first kind of algorithm approach, and Eric for the second one. So congrats both.
Okay, awesome. Congratulations, Irene and Eric. All right, so I guess that's it for today. Thanks so much, Ronald. If you found this helpful or useful, please let us know. Give us a like, and feel free to leave comments. We'd love to hear what you think of our critique. Till next time, we'll talk to you soon. Bye.
Bye-bye.